Okay, folks, I'm Jeffrey Fox. This is the Space and Energy Unit, and it's the lesson on energy. And this is part of the AI First Engineering curriculum. Here we are. This is space, which is staggering in my opinion. I am just so astonished to see how impressive the industry contribution to space is. I spent a lot of my life in Pasadena, California, next to Jet Propulsion Lab, which is a highly successful NASA lab. But if I look at the operation of, and then my view of commercial space was companies like Boeing and SAIC and ones which really were not very impressive, very bureaucratic. But the new companies in space are so energetic and exciting, and they're entrepreneurial. It's just an incredible change. I should say the um, rather bureaucratic attitude of previous space companies isn't necessarily the fault of the companies. It was probably the fault of the government funding, because they really didn't separate themselves from government. They didn't have private investments directly in them. All right, so here we have two slides. One says space supporting AI. The next will have AI supporting space. And AI can actually be helped by space in the global navigation, because you can have the global navigation satellite systems which tell people where you are. Those clearly are very important for AI applications and mapping and things. They're also important in logistics, because you can use the geospatial location of everything to do a much better job of delivery. There's an area which is Earth observation, which is the satellites looking down, capturing images, and clearly that observation can be optimized, and the images themselves are hugely valuable, because as well as some rather obvious military cases, they have disaster applications, identification of deforestation, and things like that. Ice sheets, we use them in polar science. And of course, the satellites enable communication, which collects the data from edge devices and sends them off to the cloud for training. Okay, here we have AI supporting space. And this article identified 4 areas. Manufacturing. Remember, modern manufacturing or digital manufacturing has smart machines, all of which are AI controlled. And space can't survive without high quality manufacturing. Satellites, rockets are all manufacturing intensive. Imaging. AI can choose the best images to take. And AI, as we discussed, is rewarded by deducing things from the image in the previous slide. Telemetry and control. AI is used to telemetry is all the things sent back from the space, and you can both monitor that telemetry and send feedback back to optimize the activities in the satellites. SpaceX, this very well-known commercial company, has implemented satellite collision by AI, and it can also do all sorts of other things to optimize the switching on of rockets and switching off of rockets, and generally avoiding collisions and everything. Slightly more subtle one is dynamic spectrum use. The satellite can actually learn to transmit using the most appropriate frequencies for interference and power and everything like that. That's a deep learning application. All right, here is an interesting news release from 2011. That was 9 years ago, almost exactly. And there's refers back to a little article a few months before, and it's basically saying, wow, if we made rockets like self-driving cars, the rockets could do even better. So launch vehicles with AI. Here is this series of rockets. Here's version number 4, Epsilon 4, and it was recently launched, and it had actually 7 smaller satellite, actually rockets and satellites inside it, and it was testing them out. Now we can look a little bit about the private space program, namely how is the private sector basically revolutionized space. And here is the SpaceX's Space Starship rocket system in a symbolic artist impression. And by 2019, the total investment in space was almost $26 billion. That was the cumulative, but even 2019 had the largest of the annual investments. That's shown in more detail here. Here's 2019. Here is the 26 billion. Here's the actual things they can tie down to specific sectors, with satellite-related sectors being the largest, about half of that amount. Launch technology, almost another half. And then a lot smaller number in the various other instrument and other related and IT-related technologies. And here is this Starship Mark I prototype from SpaceX. Here is an interesting slide. You'll see even more detail if you go to this YouTube link here, which has a picture of, actually this is just taken from that, it was just captured at one time, and towards the end it basically records the launching of these different satellites. 57,000 satellites through 2029. It's so far launched 9,000, and 2,200 of those 9,000 are still awake, alive, still functioning. And these are the names starting in 2017 of the companies launching satellites, with SpaceX and Boeing at the bottom, Amazon in the middle, all sorts of companies. And a lot of these are low Earth orbiting satellites, which have special possibilities in terms of helping communication on Earth, because if you're low Earth orbiting, then the delay of getting to the satellite and back is not so serious, and you can use it for conventional internet applications. So here's the discussion of low Earth orbit satellites, and they are being used a lot for basically either filling in service, cell service, or creating cell service in areas which it doesn't exist because they're so rural and isolated. It is not cost effective to produce conventional network infrastructure. If you're living in a big city, conventional network infrastructure will be cheaper. So this is a lot. As you notice, Amazon was on the previous thing, and there are actually, of course, one reason Amazon and Google and people like this is if they can increase the number of people with internet connection, they can increase the number of ads they can sell, or the number of Amazon, the number of books and cookies you can sell. Here is just a little recent one about illustrating the danger of being a startup. Now, I don't think the coronavirus affects the space directly very much. On the other hand, it creates financial pressures because companies, projects are delayed, but if you're under a gun and have to produce by day X, if you're delayed, then maybe you're bankrupt. This is a company that had launched 74 satellites, and it wanted to do 10 times more, and it had established the necessary ground station infrastructure, or rather half of it. Again, SpaceX was suspending a rocket launch due to the virus. And this is a general statement. Startups are in a precarious situation because they have such a risky system that nobody wants to have risk, so they're not going to get funding, period, and they're less likely to succeed if the whole business environment has collapsed. Here is a discussion of some AI in NASA with something called the Frontier Development Lab, which came from Ames Lab, and it paired experts from NASA and the companies with students, and to do open source, publicly available, and then looking at things like finding asteroids, planets, studying the sun, and things like that. There's an interesting example here. We'll come back to this one about exoplanets. This malfunctioning sensors, so they're interesting in that you were able to learn a dead sensor. And the reason you can learn a dead sensor is you had some data when it was working, and you take that data and you establish the correlations between that data and other sensors. Then if a week later the sensor in which you're addressing is broken and forever, but the other sensors are still valid, you can use that, write a deep learning network to predict the result of this original sensor. So this is called a virtual sensor. Here is a picture of using AI to reconstruct asteroids. Here is the Eros asteroid, and it is 3D reconstruction is created by AI from the photography, and this took about 4 days with an AI program, and it would take several months with a real person to trying to do it. So that's the last, and this was developed in this NASA Frontier Development Lab. So I'm going to leave it there and have a pleasure field, have a great time in the future, and keep safe. Thank you very much.